in pressure on the states of matter. We know that a change in temperature can cause a change in the physical state of a substance. Similarly, change in pressure can also lead to a change in the physical state. Let us explain with the help of a demonstration. A gas is taken into a container. When some pressure is applied on the container, the gas particles come closer to each other. This reduces the kinetic energy of the particles. However, the particles are still quite far from each other and are still in the gaseous state. When the pressure is increased further, the gas particles come very close to each other and consequently the gas liquefies. Hence it can be concluded that a change in pressure can cause a change in the states of matter. Effects of change in temperature on the states of matter. Temperature is a major factor responsible for causing a change in the various states of matter. The change in the states of matter alters with increasing or decreasing temperatures. Let us explain with the help of activity. Take some ice in a container and heat it till it changes into liquid. Heat it further till the liquid changes into gaseous state, that is, water vapor. We observe that on increasing the temperature, solids changes to liquids and liquids to gases. This is because on heating, the particles start vibrating with greater speed. This extra energy helps the particles to overcome the interparticle force of attraction. Soon they leave their positions and start moving freely. Consequently, the substance melts. The change of solid state into liquid state is known as fusion. If the heating is continued, then the kinetic energy of liquid particles increases further. This increases the velocity of the particles, and at a certain temperature they obtain enough energy to break free from the force of attraction of the other particles. At this point, the liquid starts boiling, that is, starts changing into its gaseous state. This temperature is known as the boiling point of the liquid. On decreasing the temperature, gas changes into liquids and then changes in solids. This is because the kinetic energy decreases. So from this activity we conclude that the state of matter is interconvertible on changing the temperature. Physical nature of matter. Take 50 milliliter of water in a beaker. Mark the level of water in the beaker. Now add some salt to the beaker and stir it well with the help of a glass rod. Observe the level of water now. Add some more salt and repeat the above procedure. It was observed that the particles of salt were evenly distributed in water. Also, it was observed that the presence of salt particles did not change the level of water in the beaker. This could be possible only if the particles of salt were accommodated in between the water particles. Thus, this clearly demonstrates that space exists between water particles. We know that there is a lot of space present between the particles of matter. Particles of matter are never at rest and keep moving continuously in these free spaces. Although their movements are not visible to the naked eye, it can be proved through the following activity. Take some incense sticks and smell their fragrance. Now place them at a distance from yourself and try to smell them. You will be able to smell the fragrance of the unlit incense sticks when you are close to them. However, their fragrance will not reach you when you are at a distance from them. After this, light the incense sticks and try smelling their fragrance from a distance. However, when the incense sticks are lit, you will be able to smell their fragrance even from a distance. Hence, it can be concluded that particles of matter move continuously and their speed increases with an increase in temperature. Take an iron ball and a piece of a chalk. Try to break the iron ball by hammering it. Repeat the process with the chalk piece. You will observe that the chalk piece breaks easily, but the iron ball does not break. This is because the forces of attraction between the chalk particles are lesser than the iron particles. iron particles attract each other with a much greater force. This makes iron very hard and strong, because of which the iron ball does not break. Therefore, on the basis of the above activity, we conclude that the particles of matter attract each other. However, this force of attraction varies from matter to matter. Effects of evaporation. Take a glass and pour some cold water in it. What will you observe? You will observe small droplets on the surface of glass. Where did they come from? Let us explain. The air contains good amount of water vapors. When the cold water is poured inside the glass, surface of the glass becomes cooler, and because of that, water vapor in air come in contact on the surface of glass. As a result, water vapors lose energy and get condensed to form water drops. This phenomenon is known as cooling effect. Let us take another example in our daily life. The cooling effect caused by evaporation can be easily observed in an earthen pot which has minute pores throughout its surface. Water keeps coming out of these pores. This water absorbs heat from the pot and evaporates. This is how the water present inside the pot remains cool. Diffusion of gas. The particles in a gas move randomly in all the directions. This helps to explain why diffusion takes place in gases. Let us proceed. Soak a piece of cotton wool in ammonia solution and thus provide an ammonia gas. Also soak a piece of cotton wool in a hydrochloric acid solution to obtain hydrochloric gas. Now plug these two cotton wools in the two ends of a hollow glass tube and also plug corks in both the ends. And you will notice that in less than a minute, a white ring begins to form. This white ring is in fact a dense white solid formed by a diffusion of two gases, ammonia and hydrogen chloride. Did you notice that the white ring is formed closer to the hydrogen chloride end? So can you tell which gas traveled faster? Is it the ammonia gas or hydrogen chloride gas? That's true. It is ammonia gas. The distance between the cotton wool soaked in ammonium chloride and the dense white ring is greater than that between the cotton wool soaked in the hydrochloric acid and the dense white ring. So from this experiment we can conclude that the ammonia gas covered a greater distance inside a tube. Factors affecting the rate of evaporation. In liquids, different particles have a different amount of kinetic energy at a given temperature. So the small fraction of particles present on the surface having higher energy break away from the force of attraction that binds them with other particles and get converted into vapors. Thus, evaporation is a physical process in which a liquid changes into its gaseous state below its boiling point. For example, wet clothes can be dried in a sunny day, and that takes place due to the evaporation of water. Various factors affect the rate of evaporation. They are humidity, temperature, wind speed, and surface area. Humidity. Humidity is the amount of water vapors present in the air. Air can hold only a certain amount of water vapors at a particular temperature. Therefore, if the humidity is high, there is no space for more vapors. Here you can see that wet clothes dry faster in sunny day than in humid air, hence the rate of evaporation decreases. The rate of vaporization increases with the decreased humidity. Factors affecting the rate of evaporation. The rate of evaporation increases with increased surface area. Let us explain with the help of activity. Take a test tube and two china dishes and fill them with same amount of water. Place one china dish inside the cupboard and the other china dish and test tube under the fan. We switch on the fan, leave them for few hours and observe. We observe that the rate of vaporization is faster in china dish kept under the fan than the china dish inside the cupboard or the test tube. This is because the area outside the cupboard is bigger, and also the surface area is more in comparison to the china dish in cupboard. Thus we conclude that the rate of evaporation increases with the increased surface area and also increases with an increase in the wind speed. This is because the fast-moving air takes away the water vapors from the atmosphere, thereby decreasing its amount and making room for more. As a result, more evaporation occurs, affecting the rate of evaporation. The rate of vaporization increases with increase in temperature. Let us explain with the help of activity. Take two containers having same sizes. Fill the same amount of water in both the containers. Insert the thermometer in both the containers. Note its temperature. Place this one in the sunny day and the other in the dark place. Note its temperature and observe the water level in both containers. We observed that the water level decreases in the container kept in the sunny day, while the level of water in the container placed in the dark place remains the same. From this activity we conclude that the rate of vaporization increases with the increase in temperature. This is why the water evaporates faster in summers than in monsoons or winters. With an increase in temperature, kinetic energy of the particles also increases, and more particles are able to break through the force of attraction from other particles. Hence, they get converted into vapors. States of matter. On the basis of states of matter is classified into three states, that are solids, liquids and gaseous states. Characteristics of solids. They have a fixed size, fixed shape, fixed volume and strong intermolecular force. They have negligible compressibility. This is due to the presence of very little intermolecular space between the constituent particles of solids. Hence, they have a tendency to maintain their shape when subjected to any external force. Solids are rigid. They may break under force, but it is difficult to change their shape. Therefore, they resist a change in their shape. Although sponge is a solid, it can be still bent and compressed. This is because a sponge has small holes inside it. Air is trapped inside these holes. Air is expelled when we press or squeeze these holes. Hence, bending and squeezing is possible in case of a sponge. Characteristics of liquids. Liquids have a fixed volume, takes the shape of the container in which they are kept, weak intermolecular force of attraction, loose packing, and more compressible than solids. The characteristics of liquids can be understood in a better manner with the help of the activity. Take 100 milliliter of water in a container and pour this water in different containers such as 200 milliliter, 250 milliliter and 150 milliliter and observe the level of water. We observe that the level of water in containers differ, but amount of water is same in all the containers. We conclude that liquids have fixed volume, but the shape is not fixed. It acquired the shape according to the shape of container. Liquids are not rigid, that is, they flow freely. Liquids have more compressibility than solids. They can easily diffuse in other liquids. Let us explain with the help of activity. Take 3 syringes and remove their pistons. Also, close the nozzles of the syringes with rubber corks. Then fill one syringe with chalk pieces, the other with water, and the third filled with air. Now insert the pistons back into the syringes and push them. You will observe that the pistons of the syringes containing chalk pieces and water require a large amount of force, while the piston of the third syringe is comparatively easier to push. From this activity we conclude that the liquids are more compressible than solids and less than gaseous. In most cases, the density of a substance in the liquid state is lesser than in the solid state. Characteristics of gases. It has negligible force of attraction, undefined size, shape and volume, and flow in all the directions. Gases are highly compressible than liquids. Here you can see the piston easily moves. The rate of diffusion is very high in gases. Here you can see that gases of nitrogen intermix with air. They have lesser density than solids and liquids. Solid sublimation. When a solid directly changes into its gaseous state on heating without changing into its liquid state, the process is called sublimation. The reverse process is called deposition. Let us explain it with the help of an activity. Take 1 gram of iodine balls in the china dish. Cover it with an inverted funnel. Plug the inverted funnel with cotton. Heat this content on the Bunsen burner and observe. You observe that some violet vapors are formed inside the funnel. Now remove the burner, and after some time you notice that the vapors get deposited on the sides of the funnel on cooling. Look at the china dish. There no liquid is formed. So from this activity we conclude that some solid changes into gaseous states without changing in liquid state. Some examples of sublime solids are camphor, ammonium chloride, iodine, naphthalene, and benzoic acids, etc.